In this video, I'm going to demonstrate creating the TKG Shared Services Cluster. The primary aim of the TKG Shared Services Cluster is to provide shared services across any guest clusters or workload clusters that are provisioned from within the same TKG instance. Some examples of shared services would be something like an image registry, so a deployment of Harbor which is shared across workload clusters, or potentially a monitoring system such as Prometheus, which can integrate metrics from several workload clusters. It's important to remember that each TKG instance can only have one shared services cluster. The procedures that we're going to use to deploy the shared services cluster and the workload cluster are potentially almost the same. The only difference is that you add the Tanzu-services label to the shared services cluster as its cluster role. And this label then identifies the shared services cluster to the management cluster and the workload clusters that are provisioned from that management cluster. So to provision the shared services cluster from within the Tanzu Mission Control UI, we're going to navigate to Clusters, and then we're going to click Create Cluster and create Tanzu Kubernetes Grid Cluster. A new window will appear asking us to identify the management cluster that we want to use in order to deploy this shared services cluster. So we're going to select the management cluster that we created previously, which is this one, TKG 160-MGMT-NSXT, and then we're going to click Continue to Create Cluster. Now you'll see a number of configuration sections here that we'll need to complete in order to create the cluster. The first is to choose a provisioner. So you'll remember in the last video we created a unique namespace called TKG-clusters, which we were going to use as the provisioner in order to deploy our clusters to. So I'm going to select that TKG-clusters as the provisioner, and then I'm going to click Next. So the next thing we need to do is assign a name to this cluster. So in our case, I'm going to call this TKG 160-shared SVC-NSX. For the cluster group, I'm going to leave it as default, and I'm going to leave the rest of these parameters as default and click Next. So the next section is going to ask us some configuration parameters about our environment. So our data center is the data center defined within our vSphere environment. I'm going to leave that as VC01. Kubernetes version, I'm going to leave that as version 1.23.8. And the OS version I'm going to leave as Photon 3 AMD 64. So the next entry required is the SSH public key. And this will be the SSH public private key we generated in earlier videos in order to be able to SSH to any of the nodes that we provision as part of the cluster. So I'm just going to paste our SSH public key into this box. And we now move on to Kubernetes network defaults. So the first parameter we're going to choose is the network that the nodes in this cluster are connected to. So again, from previous videos, you'll remember we created a specific logical segment for the shared services cluster. So I'm going to select that, and that was called TKG-SS-LS. For the pod sider and the server sider, I'm going to leave those as default. No proxy configuration is required for this environment, so I'm going to move on by clicking Next. So the next section requires us to specify some resource parameters for our vSphere environment. So the first thing we're going to configure is the resource pools. And again, from previous videos, you'll remember we created a specific resource pool for the shared services cluster. So I'm going to select that here. And same for the VM folder. We created a specific VM folder for the shared services cluster VMs. So I'm going to select that. And then the data store, we've only got one data store in this environment, which is the vSAN data store. So I'm going to leave that as selected. I'm then going to click Next. Now the next section defines how we want the control plane to be deployed. So in our case, the shared services cluster is pretty important if it's providing shared services to the rest of the clusters that are provisioned as part of our TKG instance. So we're going to make this highly available. And for the instance type, I'm going to make it extra large as I don't really have any resource constraints in my environment. For the control plane endpoint, I'm going to leave this blank because that's automatically defined as part of our integration with the NSXT advanced load balancer. And the API server port, I'm going to leave as default. And I'm then going to click next. So the next part of our configuration defines the node pool settings. So this is how our worker nodes are deployed. So in our case, again, I want this to be highly available. So I'm going to define 3 worker nodes, and the instance type, again, I'm going to define as extra large. And I'm then going to click next. So the last section of configuration is advanced settings. And you'll remember from previous videos that we defined a label that allowed us to automatically integrate with the NSXT Advanced Load Balancer. So I'm going to add that label, and the parameter we defined for that label was type equal management. So I'm just going to define that here. So type management. And that should be all the settings we need in order to create this cluster. So I'm going to click the Create Cluster button. So you will see TMC updates and say that our cluster is being created. In order to see what's happening behind the scenes, I'm just going to switch over to the vCenter UI. So switching over to the vCenter UI, we should now start to see some objects being created. So we can see our initial control plane VM starting to get created. So we just need to wait for the rest. So this could take a while, so I'm just going to fast forward it. So it looks like the cluster creation has completed. And if we have a look at some of the objects that have been created as part of the cluster creation, we can see that our 3 control plane and 3 worker node VMs have been created as expected. And these have been created under the TKG shared service resource pool. We can also see that 2 additional service engines have been created. And that's because the VMs that form part of this cluster have been connected to a network which is separate from the management network. So you'll remember that the management network has its own service engine group. And so this is the first cluster that's being created and connected to a network that is part of our other service engine group. So in order to accommodate that, 2 additional service engine virtual machines have been created. So if we move over to the folders view, we can see that the 6 VMs that have been created are all organized under the TKG-SS-VMs folder, which we created specifically for the shared services cluster. So I'm now going to switch back over to the TMC UI to see how the cluster creation status is being reported. So switching back to the TMC UI, we can see that our new cluster is now listing with status unknown, but the status of this was last updated 15 minutes ago. So let's refresh this now, and we can see that our cluster is now listing as healthy. All of the TMC agents and extensions are listing as healthy as well, and everything looks to be in a good state. So I'm just going to do 2 final validations to make sure that everything is deployed correctly. The first thing I'm going to do is switch over to the NSXT UI. So in the NSX-T UI, I'm just going to validate that our VMs have been connected to the correct logical segments. So if we have a look here, we can see the segment that's been created for the shared services VMs. And we can see that it has 6 ports connected to it. So that's expected. That's the 6 ports from our 6 VMs that have been created. And if we have a look at the network topology, we can see our shared services segment here, and we can see that it has 6 VMs connected to it. So that all looks correct. And for our final validation, I'm just going to switch over to the NSX ALB UI. So in the NSX ALB UI, you will now see that there are 2 virtual services. So there is a second virtual service that has been created, and this is specifically for our shared service cluster that was created. So if I expand this, you can see the 3 nodes that have been created as part of the control plane, and the virtual service is load balancing port 6443, which is the port for the Kubernetes API server. So you will remember from the start of this video, one of the differences for the shared services cluster that I mentioned was that it had a specific label configuration. So I'm just going to switch over to the Bootstrap machine now, and we are going to configure that label on the shared services cluster. So back on the Bootstrap machine, I'm just going to issue the Tanzu cluster list command to make sure that it is aware of our shared services cluster we created. So we can see the output there is listing our shared services cluster correctly. Under that custom namespace we created called tkg-clusters, and you can see its status is running with the expected control plane and worker node count. So I'm now going to issue the command to add the required label to the shared services cluster, and the command to do that is kubectl label the specific cluster that we're adding that label to, which is the shared service cluster name, and then we're adding the Tanzu-services label to the shared services cluster as its cluster role. So we can see that that label has been added correctly, and if we now issue a Tanzu cluster list, we can see that the roles field, which was blank before, now contains Tanzu-services. So that brings us to the end of this video. Thank you for watching.